the last time, the one thing we did the the maximum value profit function. So there we discussed things and now here let's say a very simple production function Q equal LK, and the profit they become P Q C. What we are going to do here, they take the quantity, then the profit become P LK. The minus C is between the W L K. So that is the cost side. The first order condition what we discussed last time for profit maximization, or find the maximum value, differentiate this profit function because there's no constraint. That is a straightforward exercise. And when you differentiate, let's say the profit function, the decision variable, but we have the number of labor, number of capital, ultimately when find the maximum optimal value, number of labors or the labor demand or the number of capital recruitment, we can get it. When you differentiate with respect L, what you get the answer P K minus W, and the optimal level, the first order condition, we know that equal to 0. So there we get the one equation, and also the K also unknown. The K also unknown. When you differentiate with respect K, we get the answer P L minus R. So that equal to 0. That is the first order condition. And you get the second equation. You got the second equation. Now with this, the first, I think what we can do is the first equation divide by that what we did the last time. The second equation, there I'll get K divide by L equal W divided by R. With that, we can get, let's say, third equation. We can rewrite that, let's say, L R K W. Now this one that we can plug into the second equation, then we can get the answer to K. Basically what we get the capital input demand function is the function of WP and R. WP and R. Similarly, you can get the demand for, I think, so here must be the R, here P. So this input demand function, this input demand function, if we plug into the profit function, we can get the maximum value the maximum value the profit function. That equal what we have the profit function P L K minus W L W L minus R K. Now we plug this optimal value, which means the L star, K star, L star, and the K star. Then you can get the maximum value, the profit function. Then ultimately, what you get the maximum value profit function of W, R, and P, which is equal minus W, R divided by P. So this is what we call the maximum value profit function. Now, the last time what we did is, when you differentiate this with respect to its parameter, what we call Hotelin lemma, the Hotelin is the person introduced the concept what we call Hotelin lemma. Now, for example, when you differentiate the maximum value profit function with respect W, you get the labor demand function. So that what happened practically, you collect the data, then you can get wage rate. that's available already, and the interest rate and the market price. So you estimate the profit function with that value. So when you differentiate with respect W, you get the labor input demand function. Similarly, when you differentiate with respect R, that's what we call Hotelling lemma, you get the capital input demand function. So that is also function of W or input prices and the market prices. When you differentiate this maximum value profit function with respect Q, P, when you differentiate with respect P, you get the answer to Q, sorry, which means the output function, that is also function of input price and the market price of the final output. So this particular example is getting W R, the P powered 2. So this is the output function. Now you can see all the parameter all here, the variable readily available. You can get from the market, time series, so even the collecting cross-sectional you can do. Then you can estimate and you can do that. So now in terms of the exam, what I'm going to do, this production function, either I give you kind of a production function like this, or maybe you can practice with the kind of a standard production function. A is the technological part or capture the other, all the, okay, and the L power to lambda and K power to beta. With that, try to get the maximum value profit function, then do the Hotelling lemma and get the input demand function as well as the output function with this, right? That's the exam questions, and you have to practice those things. The other one, what we discussed, the minimum value cost function. The minimum value cost function. So the last time I give an example also. Let's just quickly look at again to derive the minimum value cost function and the given simple production function. Let's say Q equal L A. Now here, the objective is to minimize cost. Cost is the labor budget or labor cost. If it is against the capital. Now here the small issue, you minimize cost. That's what we did. we try to reach the minimum cost, but the given amount of output, not like the profit function. Here the constraint there, there you reach the optimal point. This happens subject to given amount of output. This is the production function. Example I gave you, LK. So now the problem is not the single equation. And the last time what we introduced, we have to write the Lagrangian, the function, Lagrangian equation. So that first write the objective function, then add the constraint is equal to 0 constraint, and the exam you have to do the same exercise, but most probably the different production function, right? This is what you call Lagrangian equation, and any other constraint in the practically, in addition to this one constraint, you might have learned in the macroeconomics, or if you don't monitor and those economics, so many constraints, how monetary policy work and the financial, the macro policies, they work. But here I take only the one constraint. So with that, again, we have some unknown variable or decision variable, labor and the capital. They are the what you are going to find, how many number of labors and the capital at the optimal level. And also this lambda also, that consider the shadow, the price, and release the little constraint. It's a meaning idea, how it's impact to the cost. So we differentiate this one with respect L to get the first order condition K and the lambda. So this is going to be this become the first order condition or necessary condition. When you differentiate, you get the W minus lambda K and set equal to 0, but that is the first order condition, because the when you differentiate the first time, it becomes the slope, and the optimal level, minimum or maximum, slope becomes 0. Then R lambda L, that's also equal to 0. You get the two equation there. The equation is become automatically the constraint when you differentiate with respect lambda Q minus LK. So use the optimal amount of or maximum, and that also set equal to 0. This equation, what you right now you have, from there, with starting point, maybe first equation, sorry. The first equation, you can divide by the second equation, then you get this point, intercept point, which means the price ratio, input price ratio equal to MRPS. Here the optimal point price ratio, that is the slope of the isocost curve, equal to slope of the isoquant curve, that is MRTS. So those things we discussed. Now MRTS, how to find MRTS? the marginal product of labor divided by the marginal product of capital. We did all of them. And here, exactly what you get the marginal product of labor, because we differentiate the production function. And here, marginal product of capital. So we get another equation. With that, you plug into third equation, you can find the labor, indirect labor input demand function, and the indirect capital input demand function. So this particular exercise, what you get is here, you can do the exercise. Definitely, the exam, I'm going to give a question. So these two function, input demand function you get, you can see the function of input price and the quantity. So when you plug this into the cost, equation here, so this is the cost. If you plug them into here, the L hat and the K hat, what you got the optimal value, which means this value, you will get the minimum value cost function. The minimum value cost function. Then the minimum value cost function, now you can see, you can even estimate the function of input prices, W, R, and Q. So those from the field secondary data or even the primary data you can collect, and you can estimate the minimum value cost function. In this particular exercise, you plug here value. Here also you can plug. With that, ultimately you get the, for this example, minimum value cost function as, I use the C star, O. After the lecture, you practice those things. WRQ power O star. So this becomes the what we need, the minimum value cost function. In the exam, you get around 8 marks or sometimes 10 marks also. Doing this thing in the slide, really, because you have to write first. If I give the exam question like that, this objective, the function here, and or in other words, our problem, and then Lagrangian equation, this together maybe 2-3 marks you get. Then the first order condition equation, there also maybe 3 marks. After that, you can derive the labor and capital indirect input function, and then you can derive the minimum value cost function. Now, if you take the minimum value cost function, it is particular production function what we got here. I'm going to rewrite 2 W R Q, the power O square. Now, when you differentiate this product minimum value cost function with respective parameter, here W R Q, what we call the exercise Shepherd lemma. Shepherd lemma. Which means you differentiate the minimum value cost function with respect W, you definitely get the
Sir,
L.
Sorry to disturb you. I'm Sana. Please make sure whether the lecture is being recorded, sir. There was a message. I think it's not recording.
Recording can't record or what?
Yeah, please check it, sir.
Echo coming. I can't see from here anything. I don't know. Okay. So when you differentiate or perform the Shepherd lemma, you get the input demand function labor. Like a same again, R, W, Q. And similarly, when you differentiate respect R, you get the capital input demand function. Now, this exercise we call Shepherd lemma. And the exam also I may give, like previously, like say the different production function, you should be able to find minimum value cost function in the proposed Shepherd lemma. Those things you should be able to do. Now, with that, if little move on to the productions curve, the last point related to production, what we did, now if you look at the short run, just to summarize how the curves link each other. In case of short run, let's say the capital is given some amount, let's say 4. Now what happened? You have an isoquant curve. Now the short run, let's say the isoquant curve here, value 100, output 200, 250, let's say 300. Now, if you remember what you get the short run, the production function with the output, with those value, the labor, let's say we recruit L1 amount, output is 100. Now, when the labor increase, output increase to 200. Labor further increase, let's say 4, 8, 12, like that. Output increase 250. So the point you can see A, B, C, like D. Labor further increase, you can see the output increase 300, somewhere here. Now, if you remember, we draw the short-run production function here. How this happened. And with that, we already draw the marginal product function and also average. So this to visualize the short run. Now the what I did is here for the exam, I may give you the short run situation like a number of capital, let's say 10 or kind of situation, and the short run number of labors and output. With that, you should be able to find average product, the marginal product, and also given the wage rate and R and the market price. You should be able to find total cost, average cost, the marginal cost, this value also you should be able to find. With that, since the prices also given, you could find here profit maximum output and at that point the labor requirement also short run. And so that may be one exam question, but I'm not sure. Definitely, I'll give that question, right? Now, one more thing, before I move to the cost side, what you have to understand, how we differentiate or how you identify technical progress in the sense even the macro level or the micro level using the production function. Let's say we use the A to capture technological or technical that change over time. That's what use the T. The is a function, the other part, the other input, the labor. Labor also change over time to capture real dynamic situation. And the capital, that is also changed. This is the production and the function here. If you remember the macroeconomic solo growth model, they are the labor change and the capital also change, impact the GDP at a macro level, and also economic growth, but contribution, technological changes or technical improvement, like we did in the first class, production function. Now, economic growth, this is the macro picture, means this production function shift a little bit up. So this shift due to technological improvement from this component. That's what I'm going to check either right now. Now is consider A, the component A here, all the other than the labor and capital or input determine the output or rate of growth. Mainly this happened technological improvement. Now what I'm going to do, differentiate this, see this dynamic factor, differentiate this production function with respect to yeah, you can find the changes, the time, so differentiate with respect to t. When you differentiate this production function with respect to t, what you get is a also function of t so then we have to apply the chain rule. Here, the L and K also function of t. In this case, I am now not using the t, but has to be inside these two variable also, but I drop here, otherwise I have to write lot. The plus A L K the second equation I got, just differentiate the production function with respect. Now here, one more thing to go further. This, the production without technology. Equal, I mean, just taking this equation one, production function, you can rewrite like Q divided by A. Q divided by A. Now with that, I rewrite the equation number 2 because my exercise is to try to find out the contribution from the technological improvement to the economic growth and separately the labor growth and capital growth, what impact to the, that is the final task. Now what I'm going to do, replace with this term, this equation I rewrite. So the my cursor very difficult here, take time. So nothing changes, right? Same dA, which means differentiate the A with respect to T. And here for production function I replace as QA. So that is from this plus for this A also I can rewrite the Q divided by from this term and rearranging this one. And after that, this part, you can see the differentiate production function with respect to T. But here chain rule apply because inside the L also, in other words, the L and capital or input also change over time. When you take that out, we have to apply the chain rule there. When the differentiate, I use here F, which indicate all these L and K inside those with respect, sorry. K, but the last purpose is the T, then we have to use the chain rule. Plus, similar thing for the labor. And also DL over DT. So that. Now here we already reached, I think, what we need. But before that, what we are interested in, have to look at and growth. This is the change of rate, and we have to look at the rate of growth of output, which means it's come D Q DT. That is the change of rate with the time. And if you divide by Q this one, sorry, divide by Q, you get the growth rate of growth of output or growth rate, you get that. So the other side, then you can repeat it yourself. Here the first part, when you divide by Q, this cutoff, then you have leftover D A dt divide by A plus now here what I'm going to do, when you divide the Q, this Q goes anyway. So this part, just to understand, sorry. This part, I hope you know that that is become the marginal product of capital. So this part become marginal product of capital. And here, this part, the marginal product of labor, the marginal product of labor. Now here, again this component, this one, I multiply by K over K. After remove the bracket, the second part I multiply by L over L. You can see nothing will happen. Then what we get, here Q over 1 this part, I use the different color. So this part, dk or dt, and divide by k. If I rewrite somewhere here, k dt divide by k. So when you multiply k over k, so that happened. You know, that is equal. That is equal change in or growth in capital, right? The capital stock, I say the GK, that part. The rest of I already say this is the MPK. This K out, here coming K, because this K, which means 1 over AP average product. Ultimately, it's coming marginal product of capital divided by average product of capital, and the plus, similarly the labor, the marginal product of, sorry, I missed one part here. That is the GK, multiply GK, the labor growth, plus marginal product of labor divided by average product of labor, and the labor growth, GL. Now here, this part and this part, we did some time back. But again, if I look at MPK divided by average product of capital, so that is one part. The other one, marginal product of labor divided by average product of labor. Now, the 2 weeks ago, we did exercise to find the labor input elasticity. If you remember, how to get is production is differentiate with respect L. So that is the formula what you get the labor elasticity. Now here, the first part is the marginal product of labor. The second part, the reciprocal, 1 divided by APL, which means labor elasticity equal MPL divided by APL. APL means average product labor. Similarly, you can get the capital input elasticity, the marginal product of capital divided by average product of capital. Now remember, some time back we did, we have the average product curve. This is the average product of labor. We have the marginal, the product of labor. Now, look at the elasticity. This point, we found since both equal, elasticity equal to 1. That's the stage 2. Stage 3, elasticity become negative. Why? Because the marginal product negative, the elasticity become negative. Here, the boundary is 2 and stage 3. Since the marginal product is 0, elasticity becomes 0. Because here becomes 0, this 0. And the stage 1, you can see the marginal product is greater than average product. So the elasticity become greater than 1. So we did this exercise just to redo. Now my point here, we get the labor elasticity and go back here. This part, the labor elasticity, labor input, and we have the labor growth plus, sorry, this is not labor, this is capital, sorry. Next one, the labor elasticity. And the labor growth. Capitalist stock growth, the labor, and the elasticity. This part you can see that is the residual growth, the technical side. So if I use the GA here, it basically to capture all the other impact. And if you include all the variable, not only the labor and capital, this become completely a technological improvement, right? Now, the left-hand side, this part, you can see growth rate or rate of change of output growth rate. Now, what to notice is this last equation here. The economic growth in terms of, if you take the single firms also, the firm's growth depend on the labor growth. Now, let's say Sri Lankan economy, the economic growth came with the labor increase or decrease with the labor growth. And the other component, the capital stock growth. And here, the elasticity, that is also play a role, labor elasticity. Now, what happened really, in the macroeconomics, you have done the solo growth model. Solo growth model. What he did really in 1956, if I remember, he estimated its original model, USA economic growth data from 1909 to 1949. So during this, the average growth he found, the average growth, the US economy during this period, what he found, 2.75%. And the labor growth in the US economy at the time, they found only 1%. The population growth is very, the labor growth happened. The capital stock grow 1.75%. And also, this is the production function. He found the capital input elasticity 0.35, and the labor elasticity 0.65. 0.65. Now, what he concluded that the USA economy grow during this period mainly due to the rest of this residual part is the technological improvement. The contribution is 1.5. You can see the capitalistic, the key, then the technological improvement. Really what happened, uh, the government or country contribute more capital stock. It's a part of the technical changes also happen. Now, if you can estimate this growth model next countries, definitely this figure much more higher than the other one because those countries' economic growth due to mainly technological improvement. Another small thing is not related to this one, and these two, you can see adding these two equal to 1. Labor plus which one output velocity here total equal to 1. What does mean this production function? If you get the Cobb-Douglas type production function, L, the coefficient here 65, 0.65. Here you get the 3 part, which mean this adding this equal to 1 mean the economy is in the constant return to scale. Constant return to scale. Constant return to scale. Exactly, if you look at here, the second stage, the producers produce in the second stage. Otherwise, the labor elasticity, sorry, the elasticity must be greater than 1. Yeah. Somewhere here. The exam, I may give this question to identify the, let's say, the growth and the contribution from the economic, let's say, the labor growth, capital growth, and technological improvement part, and do the analysis. I may give one question. Now, let's quickly move to the cost side. Just to identify the cost curves and their behavior and link to the profit maximization level. Now here the concept what we usually take the total cost, and we know the total cost equal WL in case of two variable case. Okay. Now here the short run and the long run, if you look at the short run, at least one input keep it constant, let's say the capital, definitely the market given R and W also given. Now there you can get the variable cost plus fixed cost equal total cost. Now in the short run, this is the short run situation. Now the short run, we can find the dividing this by Q. Q, you can find the average total cost. So it has the two component average variable cost and the average fixed cost. Now, if you look at the total cost, the function of Q, we have a component as fixed cost, short run, we have the component variable cost, and fixed variable cost together, we have the total cost. Now, this difference is always same, that is become the fixed cost. So coming out from here. Now, when you look at the average, here we can draw. You have the average fixed cost continuously decreasing with the output. And we have another two component average variable, average variable cost. And also the average total cost. Now, the shape of these average cost curves are usually what we consider the U shape, and come to the minimum point and again start to increase. Again start to increase. Now, another component here, if you differentiate the total cost curve, with respect Q, you get the slope of the total cost curve. That's what we get the marginal cost curve. Since the fixed cost is given constant, same result you get if you differentiate the variable cost curve. With respect Q. So that is the slope of the either total cost curve in the different places or variable cost. That goes here. Again, U shape usually, and as a marginal cost curve. So here you must notice very important relationship, though I did not here fully capture. The marginal cost curve goes the minimum point of the average cost curves. Marginal cost curves goes a minimum point of the average cost curve. The other relationship, here look at if the average cost curve has a negative slope, here the marginal cost is less than average cost. When the average cost has a positive slope, that means the marginal cost is greater than average cost. So that's how. It doesn't matter the short run and the long run, same that relationship. Maybe I'll ask the relationship between the marginal cost curve and average cost curve. Before that, to prove, let me look at the long run situation. Now, long run, what happened? There is no any fixed cost, and in that way, total cost equal to variable cost. All the cost component are variable. So there you can see to find the average cost. We just C divided by Q. The marginal cost, either total cost or the total cost equal variable cost, differentiate, or what you, I mean, all the variable cost, then differentiate Q, you get the marginal cost. Now here, the average cost curve, only one average cost curve, the long run, like here. That is also the pattern, but usually, sorry, that is U-shape, but compared to the short run cost curve, it's a little bit flatter. And now, there are also the marginal cost curve, same relationship like the short run goes to minimum point, the average cost curve, minimum point average cost curve. Now, here also you can notice the same relationship. The exam, I may ask to find the relationship, then you have to explain, you have to draw, and the algebra, you have to prove it also. You have to prove it. So how to prove it? Now, let's say the average cost equal we did here C divide by Q. That is the average cost. Now, with this equation number 1, we can rewrite like a C equal AC time Q. So that's the same equation, but I rearrange a little bit and you can see total cost. Of course, the average cost multiply quantity, the total cost. But now what is the marginal cost? You differentiate the total cost with Q. There you get marginal cost. Marginal. What happens when you differentiate this is because the average cost also function of Q. So you get the answer AC plus Q dA dQ. Now here we got a very important relationship here, the marginal cost and average cost. Now this part in this equation number 3, this part, this AC, slope of the average cost curve. Now here, look at this point A, slope of the average cost curve is equal to 0, which means this whole entire part becomes 0. Then at that point, it has marginal cost curve crossing. So that there MC equal AC. MC equal AC. Now look at if the slope is positive, let's say this part is positive, slope is positive. What we are talking about, average cost curve, this range. This range. Now there, to be positive, the marginal cost must less than average cost. Now, to be this equal here, that must be whether positive sum plus AC become marginal. So that's what we get that here. Now imagine the situation, this average cost curve, the negative slope, right? What we are talking about, this increase in average cost curve. There, it's in the negative, for example, let's say here average cost is 8. With that negative, and this become negative somewhere altogether, let's say 2. The marginal cost, this slope is, this is not negative, this is positive side. If it is positive, adding the marginal cost must be greater, like a 10. This range, the marginal cost must be greater than the average cost. The average cost. Now, another important thing, let me give another 10 minutes or maybe 5 minutes. Now you saw that in the production side, the average cost curves goes like this. Sorry, average product curves goes like that. And the cost side, now you saw that average cost curves goes like this. So like a mirror reflection. And here the marginal cost, so that here is going to minimum point, and the production side, when you look at the marginal product curve, you saw that like here. Now you see that relationship, average product and the marginal product. The average product and average cost, the marginal product and the marginal cost. Now look at just to see what is average cost. The average cost is total cost will be W L plus R K in case of two input case, divide by Q. So that is the average. Now let's say, assuming that the short run, this become constant. It doesn't matter the long run. So then what we have? W L divide by Q equal average. Equal average cost. Now this second equation, you can see right hand side two component, one is W, other one is L. Divide by Q. That's no meaning, but you know what is Q divided by L. So that is the average product of labor, which means L divided by Q mean 1 divided by APL. So if I replace this one here, then what I can get AC equal W divided by APL. Now you can see here one good relationship. This equation number 3. Now the wage rate is given. So that is a given value. Now look at here. If the wage rate is given when the average product increase, since the W is constant, I'm talking about the average product increase. This part, like here, and in other words, our stage 1, and the average product increase, average cost must decrease because the W is given constant. So that you can see here, average cost curves goes down. Now, the opposite, let's say the average product decrease. Since this is constant, average cost must increase. So what we are talking about this way. This way. And also, just look at the average product come to the maximum point. Now what we are talking about point is A here. When we come to the maximum value, the maximum point, here, then average cost must be the minimum point. You can see here, come to minimum point. Come to minimum point. And now another, what we discussed, producers take the decision, second stage, we discussed 2 weeks ago. And also take the decision diminishing marginal return state. Now here, stage 1 increase in return. Stage 3 is negative return. Now, right, what we use the concept, increase in return, what we use the concept using the long run cost curve, we call economics of scale. Economics of scale. Sorry, the economic scale. Here the positive side of the average cost curve, there we got the diminishing production side. Here what we call diseconomies of scale. Diseconomies of scale. The minimum point here, the average cost curve, what we call minimum efficient scale. Minimum efficient scale. Now minimum efficient scale. Now I'll go to another slide. Let me. Now what we had, for example, the long run. So we apply this economic scale, this economic scale, and the minimum efficient long run. Now let's say the long run average cost curve you have. Now they are up to here. You can see the economic scale. So some period here, the minimum point, you can take the minimum efficient scale fraction. So then reach to the diseconomic scale. Diseconomic scale. Now point here, now let's say the firm, why get the economic scale? What does mean? The firm expands certain level, the unit cost reducing. Certainly. After that, as it comes to the minimum efficient scale, then this economic scale. Why this happen? Two ways happen this economic scale. One way, what we call internal economic scale. The other, what we call external economic scale. What does mean these two concepts? Now, internal economic scale mean, let's say, imagine you have the micro level firm somewhere here, few laborers and micro level firm. Now, when you expand certain level, like say small, medium, even the large, your firm, you get the workers, management, different areas of specialization. A very small firm, everything, maybe 2-3 people has to do, no specialization, no division of labor and things can division. But when a firm slightly become larger, kind of medium or micro level or small level, then within the firm you have the specialized group. For marketing, maybe they start a different division also. Human resource management also, research also. And the division they specialize and the teamwork also happen. With that is the benefit to reduce the average cost with the specialization and teamwork internal, then the average cost goes down gradually. It's come to internal marketing what you call marketing economy scale. Marketing side. Human resource side is also get the economy scale. Technology side, all the areas, management, get the economy scale. That is the internal, within the firm, get the internal division and the management and different labor specialization. It get the advantage, then the productivity improve. When the productivity improve mean, you see, average product curve increase and average cost in down. Now, when single firm doing like that, it's an industrial economics, what we learn, it's as a cluster. This trickle down effect, we call neighborhood effect, basically, or cluster effect. The other firms on the industry also getting that advantage. For example, let's say your firm with this specialization introduce new technology. That is one example, even related to the marketing. With some time, nowadays, of course, the online and smart economy, within few seconds, all the other firms within the industry, as well as the other industries also, get that knowledge, get that innovation, get that speed. For that, the industry also expand. Industry cost also getting down. That's what we call external economic scale. Basically, the cluster. Now, one example, if you remember, sometime long time, even now, so many examples. I'll take example, let's say the teller machine. In Sri Lanka, the Sampath Bank, within the couple of months and all the other bank, is like that because the world is competitive and with the information and the technology is get the trickle down effect and basically the neighborhood effect, and the other firms also get it. So these two ways, internal economic scale and external economic scale, the average cost curve getting down and the unit cost reducing continues. So, but what happened, the firm expand certain level, let's say they become what we call too big to handle. For example, you might have some experience as a manager, also co-workers. When the management, top management pass a message, and one thing is the communication and different message goes. And that communication gap also there. Whatever thing is this complexity in the become too big, handling costs, management costs, and those costs become increased and reach this economic scale. Economic scale. That really reflect, last 5 minutes, let me, when you study the industrial economics, in 1950, early 1960, the concept what we learned, one umbrella hierarchy firm concept. Firm try to set in one umbrella, I mean, produce whatever the through value chain or supply chain, everything within the firm. Now, I used to take the example, Toyota company, whatever the company, if you take like that in 1950, 1960. But they realized in 1980 something, and the average cost getting increased and the range this economy too big to handle. Then what happened? They try to produce main thing, other component try to buy from outside. Now let's say the mother company here, A, the component. There are several small producers produce those components. For example, in the car case tires. Now they try to do in especially 1980, 1990, buy from this market and stay in the small. That's why the smallness beauty book also came. And but there are also the Williamson identify that Williamson hierarchy and the market books. If you read it, you got the Nobel Prize also. There also you found that when you deal with the market, due to several reasons, one of the reasons is domestic information, other thing also the government regulation and those kind of things. And this dealing with this kind of what we call transaction. When you find the market, when you do the negotiation with the firm, because otherwise they cheat you and they will give higher price or low quality. That kind of negotiation has to take place because it's not your own control now. That cost become higher. Now, let's say the one side is the firm hierarchy, try to very big, then what happened? Administrative cost become very high. Administrative cost increase. Now the firm came to smallness and depend on the market. That's why that's how Williamson wrote the book Hierarchy of the Market and try to depend on the market. But the market dependent problem is the handling and the negotiation. Those costs become high. That cost, Williamson call is transaction cost. Transaction cost increase. They are my PhD identified the research issue also. Now, in 1998 and 2000, since the transaction cost also high, firm again move back to this side. Now what happened from hierarchy to move this side and they hit the ball, transaction cost is high, then come back. Now you can see in the 1990 later and 2000, now firm tried to rely on hybrid solution based on networking. Networking. If the market players there, they keep main network with them. It can be what my thesis SME. I found that the network informal, but the formally they develop different kind of one of the example you can see the subcontract kind of depend on network. So the now firm is somewhere here try to bring the minimum efficient scale amount of production. Smallness also there, but not depend on the market. Keep the network, different ways you do that, and keep the production economics of scale level. Now, no study I found the cost of this networking. They also identify the gap for my PhD thesis also. Cost of this network compare with the hierarchy that administrative cost mainly, and the compare with the market that is the mainly transaction cost. Transaction. So what happened? Maybe that maintain the network also with other firm that's involve cost, especially when you do the informal networking and you have to stay with them and things, and that cost also there. That happened real world with the microeconomics, how they apply to the real world situation, this economic scale and the diseconomic scale and this thing. With that, today I'll stop. And if you have any questions, we have another 3-4 minutes. And so if you don't have questions, you can leave the meeting. This slide, I may, today I want to create the slide, I say when I will share with you. And yeah, thank you very much. If you don't have any questions, you can leave the meeting. So in 1 minute, I also leave the meeting. Okay. Look like no questions, and also I found the attendance is very low, and mostly of them are PhD students. Then I don't know why, but again, send the message to others, though they come. The microeconomics final paper, I think the exam coming next month is very difficult. I don't give a very simple part. I don't give the normal marks also. If you don't come to the class, don't attend and don't work with the others and group work, and usually the past previous for this paper, the student work same way to work with the other all the papers. Otherwise, you fail the exam. I'm not going to give a very simple paper, very difficult paper. And it's really this year because I saw that the later part of the classes now very low attendance. I don't like it. And so that punishment, you get a very difficult paper. So thank you very much and see you next week.